Hey Davey, sorry for the weirdness of this, but I was thinking of how can I best show you what I'm doing here, and I thought, why don't I just make a little video? Uh, Schedules are so hard to get, and anyway, let me show you what I've been doing and how this is working. So of course I've got Stata here, and I'm using this regression here, logistic regression, to predict the SBQ cutoff, right? Do they make the cutoff for high suicidality? And then we have right here male. So what I'm doing is I'm breaking this up by gender. So I'm looking at all the predictors and saying, do the predictors differ by whether you're male or female? This little IBN here thing means that I want this to kind of be the main idea here, thing that we're breaking things up by. Put a no constant at the end here so that, well, these will be more directly interpretable rather than having a constant. But then I have sexual orientation, mission, race, whether they're married, and then I have semesters and religion for. These are C dot. I want age in here too. C dot age. I have a C dot here because these are continuous variables. When I have this in the parentheses with this pound sign, I mean I'm doing an interaction between these and then whatever else is in the parentheses here. And when it's in parentheses like this, it assumes that these are unordered categories. It assumes that they're, like sexual orientation or race or whatever. And so you have to specify the ones that are continuous. So I run that, and we get this. And basically, as we read through this, we can interpret these fairly, well, in some ways fairly directly. Females and bisexuals. Female bisexuals, female homosexuals have the highest rates. Mostly female, mostly heterosexuals next, though. Oh, I guess female asexuals next there. But we're gonna look at these and see what they actually look like. So after that, I'm gonna do margins. And I'm gonna do over sex orientation. Oh, and then over. Male. So over so it's going to break it up by this. Show me different levels or the probability of being over the SBQ cutoff, and then do it by male, by gender there. And I'm also going to put at means in here because it then holds everything else at their means. That's important. So I do the margins there, and these are the different rates. Right there, and we can do a margins plot to see that a little bit better. So doing the margins plot. So this is right here the probability of being above the cutoff. So for heterosexuals, males and females, males may be a little lower. We can do a difference test there to see if they're actually significantly lower, but they're about 20%. So about 20% of males, 20% of females are above above that cutoff. Yeah, 20% are above that cutoff. And you can see here the actual number, 20.9, and for that's female heterosexual, this is male heterosexual, 19.5. And we can test to see whether those are different if I request coefficient legend, COEFLEGEND, and I have to do post here, and it's going to give me that. So female heterosexuals, that's the name of it. That's the name that Stata has in it. Male heterosexual, that's the name that Stata has for it. But I can test for males, whether male heterosexuals equal female heterosexuals. And the answer is they do. They're the same. They're not statistically different. Male and female heterosexuals, same levels. All right. You break it down by sexual orientation, and you see here that very likely females, blue, bisexuals are higher than male bisexuals. It doesn't seem like this is going to differ at all. You see that really wide thing for female, and then this is really wide. That's not going to differ. That's possible that mostly hetero differ in terms of being above that cutoff. We can test that again. Let's do mostly heterosexual, female mostly heterosexual, and male mostly heterosexual. That's what that's called. And they're not significantly different from each other. What about those bisexuals? That looks like that probably differs. So if we take a look at that, female bisexuals, so I'm going to test female bisexuals if that's equal to male bisexuals. And yes, female bisexuals are in fact higher in that suicidality than are male bisexuals. Okay, so we can look at that by sexual orientation. Yes, controlling for all the other variables, sexual orientation does matter. So there you have it. Let's look at another one. So we're going to run this again. And let's do it by mission plans. So I'm going to, rather than do it by sexual orientation, I'm going to do it by mission. So throw a mission there over male, and then it's going to give me all of those averages. Some are blank because there just weren't enough people in that category to really make any kind of analysis, and any kind of analysis work. So then let's do our margins plot again. Okay, there's our margins plot. So those that have no mission plans, for males and females, males are higher in their suicidality than females that have no mission plans, but pretty wide confidence interval, that's not going to be significant. Those that know and have no plans, males are quite a bit higher, and I'm sure that's going to be different. So males that have no plans and females that have no plans, actually not significantly different. Maybe at the less than 0.10, but not significantly different from each other, not having plans. Now, isn't this interesting? I mean, this is fascinating to me. The males, the females who have served a mission, right? Really, quite a bit. Well, I guess this is not as fascinating as I thought it was. They're different, right? If you've served a mission, and then if you have yes but not completed, right? You're both going to be higher. Maybe females who have not completed are about probably the same as males that have no plans, but certainly higher, but not significantly different from each other. So maybe some gender differences in here along. Maybe those lines. Did we find anything? Maybe not. Maybe no significant gender differences in terms of that prediction. All right, let's look at how about married. I've got to rerun the logistic regression again. Margins, look at married. And then margins plot, run that. And you have here males. Males who are married, significantly lower likelihood of considering suicide. Females don't get any benefit from marriage on those slides. They're not worse off, but they don't seem to get any benefit from that. And that's actually, I think that's probably pretty much what you'd find, that there's a distinct marriage benefit for males, maybe not so much for females. Though it could be that men who are, have better mental health are more likely to marry. We could do religion. Now I've split religion up into quartiles. So let's run the logistic regression again. Let's do it over religiosity. Relig 4. So the 4 quartiles of religiosity. Yes. I have to do this different because this is a continuous variable. Religiosity equals 1, 1, 4. What this basically says is I want you to look at religiosity from 1 to 4 in increments of 1. Right, that makes sense. Hopefully this works. Well, how about that? Okay, it worked. I'm always surprised when it works. We have a very clear effect of religiosity here, right? Religiosity very, very clearly has an effect. If you're really low on religiosity, you're probably significantly different up here. Definitely significantly different here. Maybe significantly different here. But doesn't look like significantly different here. So men and women who are high religiosity, no significant differences on their suicidality. Let's check at the other levels though. I just want to out of curiosity here. We're going to do test that equal to that. So 2 equal to 2 there. That is significantly different. Oh, at 1, I should test at 1 too. Sorry. I think, well, no, let's do this. We want to make sure we're doing it right. That and that, significantly different. And then at level 3, and level 3, significantly different. Then I was saying that I don't think it's significantly different at level 4, but let's test that hypothesis. Yep, not significantly different. So that's kind of an interesting thing. So at the highest levels, the highest quartile of religiosity, males and females aren't any different. We can rearrange this such that it's all by sexual orientation. Maybe all these things really matter. It's not by gender. Maybe we want to look at it by sexual orientation. So I'm going to put this in here and sexor here. So now we look at that. We're going to have a lot more things omitted here, and that's because now we're breaking it by sexual orientation. So you have to have, mostly heterosexual, asexual, who are married, and those who are bisexual and married, and those who are homosexual and Hispanic, and homosexual and Asian, homosexual and other. Right? It's just you just don't have that many there. But then, for example, this would look the exact same because we already split it up by sexual orientation and gender. But you could look and see, well, what about the religiosity, right? What about the religiosity thing? Does religiosity by sexual orientation make any kind of difference? Now, one thing about this is that I'm using married in here, and so it's dropping about 1,000 participants, 20% of our participants, because they don't have that data. What I can do is I can just impute those data. We can do multiple imputation. We can do all kind of fun, fancy stuff to get that in. Okay, so let's go ahead and now look at our margins plot of that. Wow, that's hard to see, don't you think? Let's see here. Well, you have your heterosexuals. They're way down there. And for everyone, for all of these, it looks like there is a decline, right? So the higher you are, the more it's going to decline. And it's really pretty big for these asexuals. Look at the asexuals. They're up near 80. And then it just rapidly declines to, it's more than cut in half, their probability as you get to that fourth quartile. The other ones pretty much stay in lockstep as they go down, though you might say that the red, the mostly heterosexual, decline the fastest there. Of course, these asexuals, they've got a really big confidence interval. You can kind of sort of see it in there. There might be a better way to see this rather than over sex or. We could do at that, and we could do at sex or equals 1 through 5. There's 5 of them. What's there? 1 through 5. Let's see what that does. Option at not allowed. I've done something bad here. It doesn't like what I'm doing here. That's not what it is. I just have to repeat the command. Well, anyway, we can make it look bigger. All right, look a little bit better what's going on there. But that's basically what I think we might want to do with this. What are the predictors? What are the significant predictors of it? And do those predictors differ by gender or sexual orientation? We can, take a look at that and delve into that to come up with some, pretty interesting connections there. Anyway, so that's what I've been up to, and I think that might be the direction we want to go in. These kind of results, but let me know what you think.